Hello, and thank you for joining us. Today's webinar is Liquid Sample Introduction for ICP-MS, presented by Fred Smith, Product Line Technical Manager for Liquid Products for Teledyne CETAC. This webinar is being recorded and will be available within a couple of days. You will receive an email notification of its availability. Now I'll turn it over to our presenter, Fred Smith.
Thank you for the introduction, Shelley, and thank you everyone for taking time out of your day to attend the webinar. Today's webinar will concern the carousel or rotary type autosamplers for low and medium volume liquid samples that are typically used for liquid sample introduction with ICP-MS. The carousel type, and they are also termed rotary tray autosamplers, the two types that we will cover today in the webinar, are termed the ASX-110 FR micro autosampler and the ASX-112 FR micro autosampler. The FR designation behind the number designation of each autosampler stands for flowing rinse. Which means that there is a flowing rinse station to clean the sample probe between samples during a automated sequence run using the host ICP-MS. Of note is this flowing rinse is a dual type, and we'll show a number of pictures in a very short video which shows that it is a dual type or two-step flowing rinse station. So here are front views of the two autosamplers we'll be discussing today, and these are to scale. On the left is the ASX-110FR, and on the right, the ASX-112FR. Now, these autosamplers are primarily designed for applications, but not exclusively, that can include low sample volumes of 2 mils or less. These can also accommodate medium volume samples, say 5 to 15 mils. Higher purity or higher purity samples, meaning ultra trace for trace elements, and samples containing corrosives, including inorganic acids such as nitric acid, hydrochloric acid, and hydrofluoric acid. The main application areas that we'll see with these micro autosamplers include geology, semiconductors, and clinical type samples. Benefits of using this type of a micro autosampler in ICP-MS. Of course, as we've already mentioned, the dual flowing rinse station, which cleans the sample probe between samples, and that's used to help prevent sample carryover. In these two autosamplers, the flowing rinse station can be supplied with rinse liquid either with a peristaltic pump or a gas displacement pump, and we'll look at details of those later in the webinar. There is minimal y-axis assembly movement over the sample, and the y-axis assembly is what's used to position the probe over the standards in samples, and minimizing that movement can also help minimize any potential contamination of a sample or standard. These autosamplers will have one central vial rack for 24, 48, and 96 position rack, and these are for the smaller volume liquid samples, generally under 2 mils in volume. There's also the option for the Bellart style half racks, 30 or 42 position, for medium volume samples that may be, say, 5 to 15 mils. Standard vials and sample vials are made of PFA, which is a fluoropolymer, or polypropylene, so no glass is used. There's also an integrated autosampler cover. This helps prevent sample contamination. This cover also has a front door for easy access to the samples in the sample tray. The 110 and 112s are also supplied with inert or fluoropolymer sample probes that have an encapsulated carbon fiber support to keep the probe straight. And finally, there is a purge vent port for the sample tray in case fumes from very corrosive samples do need to be removed to an exhaust source. So a picture of just the ASX-110 alone I added some of the specifications to give you an idea of the footprint and the height. The footprint, of course, important when you're placing the Autosampler next to the ICP-MS and planning the setup in your laboratory. And then the dimensions for the ASX112. The ASX112 dimensions are a little bit larger as far as the footprint, but one of the things we'll talk about is the ability to stack this onto some other CETAC products that you might use in your laboratory. So a closer up view of both a 110 and a 112. This is when we have opened the front access door, and that gives you a better view of the carousel or rotary tray that contains standard vials and also the central sample rack. So on the left-hand side in the ASX110, you see a 24-position short rack. And then on the right side on an ASX112, you see a 42-position tall rack with larger sample vials for medium sample volumes. So a little bit more detail of the front door. There is a small bar latch made out of polymeric materials, of course non-metallic, that you can simply turn a quarter turn, and that allows the user to open up the front door with full access to the sample tray, both the standard and the sample vials. Power supply to the ASX110 or ASX112 is via an external 24-volt power supply. The input ranges from 100 to 240 volts input, and then you simply attach the power cable from the power supply to the power input port on the back of the ASX110 or 112. After you do that, you then turn on power to either of the Autosamplers via a front power switch. So the power switch is on the front of the unit, and once power is on, that'll be denoted by a green color LED on the front of the unit. So the power switch is not on the back panel, it is on the front panel. Communications to either the ASX110 or 112 is through either RS-232 via a serial port or a USB port. So the serial port would be denoted as COM1 and USB as USB. There is an auxiliary I/O port that can be used for the Aridusll series devices if you use something called the Quick Wash Fast Washout accessory, and that's what the AUX I/O port is used for. There's also an auxiliary module, and that can be used for any other external 24-volt device that you may want to power. In practice, mostly if you do have the Quick Wash device for an Aridusll series unit, you would be using the auxiliary I/O port. Sample probes that can be used with the ASX110 and 112 are of three types, denoted by the internal diameter of the sample probe tubing, and that ranges from 0.3 up to 0.9 millimeter ID, with 0.5 being the middle range choice. And this will depend upon the sample flow rate that you want to use when you connect it, say, to the host nebulizer of the ICP-MS. There's approximately 120 centimeters of total length, and the tubing is PTFE, and of course the carbon fiber support is encapsulated. The carbon fiber itself is not wetted during the course of the experiment. The user can cut the tubing to length, of course, to minimize the sample flow path to the host nebulizer. In addition to these probes, you can also acquire a C-flow PFA nebulizer that already incorporates a sample probe in the uptake line. And these are built for use with the Aridusll series desolvating nebulizer systems, which are popular in the geological sciences. There are three flow rates available: 50, 100, and 200 microliters per minute. For the 100, you have approximately 1,000 millimeters, or about a meter of free length available, and about 0.75 meter length available of free length for the 50 and 200 microliter per minute flow uptakes. These would attach, of course, just like the probes before on the previous slide, except this is all one piece, and the nebulizer would then insert into the nebulizer inlet port of an Aridusll nebulizer system that would then connect to your host ICP-MS. So this next slide is a closer view of the dual flowing rinse station, and the blue arrows denote a pre-rinse and a full rinse, and we'll see this in the short video that we'll have. The pre-rinse is the first port that the probe would dip into for a few seconds. Pre-rinse is usually supplied with deionized water, but it could be, say, a acid solution. Full rinse is typically an acid solution such as dilute nitric acid or dilute nitric acid HCl mix to actually wash out the sample before you move to the next. The larger hole denoted by the red arrow is the overflow, and that is drained by gravity, and we'll show some of the details of that setup. The rinse station itself, depending upon the model that you do acquire, is made of either polypropylene or PFA. The Y-arm assembly, which will actually hold the sample probe, is then attached onto a Z-drive assembly, and the Y-arm assembly can either be put in a tall, center, or short position, depending upon whether you're going to use the shorter sample racks, 24, 48, 96 position, or the taller Bellard half racks of 30 and 42 position with the larger sample vials. So that is one of the options when you do the setup. I will point out at the lower right-hand corner of the picture, you see a little bit larger piece of PVC tubing. That would be the gravity drain tube that comes from the rinse station. That will carry any overflow waste to an appropriate waste container. Now, the sample probe itself is attached into what we call a probe collar, and that's secured with a side thumb screw. And that then, with the attached sample probe, is placed on the end of the Y-arm assembly. And the reason this is done is to help prevent any potential damage to the probe. So this is denoted by use of just a gloved finger for illustrative purposes. But if the probe does strike a hard surface, such as the wall of a sample vial, in case a vial is misplaced or the autosampler is not in alignment, this will simply push up, and that will prevent bending and possibly irreversible damage to the probe. So we can call it a probe reset function, and that allows then the user to go ahead and correct the issue, such as if it's an alignment problem. So here's a little short video, and you see the first dip of the autosampler probe and then the second dip. And then depending upon the amount of time you give for the rinse, then it will stay there until the rinse is complete. That particular video, if it didn't show up on your screen, we will have available on YouTube in case there was any type of a bandwidth issue. But that just shows the two-step sequence for the probe movement for the dual rinse. Now, what you'd probably had noticed in some of the previous slides was there was a peristaltic pump. There is a peristaltic pump that's mounted onto the back panel of either the ASX-110 or the ASX-112. It's a two-channel peristaltic pump, one channel for the pre-rinse and one channel for the full rinse. You see there are a couple of lines. I don't have them in the bottles, but those are two representative bottles that you could use for the rinse solution reservoir. Say one might be filled with deionized water for the pre-rinse. The other one might have an acid mixture for the full rinse. And the peristaltic pump is then used under control of the ASX-110-112 to supply the rinse station with a flowing stream of fresh rinse solution from those reservoir bottles. Of course, again, you notice the PVC tube that leads down towards a waste receptacle. Now, there is a pump speed control utility available that can then allow the user to control the amount of rinse liquid, either water or an acid solution. For lowest flows, there is smaller ID pump tubing available, either a thermoplastic elastomer or PVC tubing, and you set the pump speed to 1% of scale. And this utility is available in the software CD for the 110 and 112. This is important if you want to minimize the use of the acid rinse and minimize the amount of acid waste that is generated, particularly if you're using a high purity grade of, say, nitric or hydrochloric acid for the probe rinse steps. There are polypropylene reservoir bottles available in the particular SP kit, what we call a spare part kit. These bottles will have modified caps with an uptake line already built in, along with a vent port. And there is one bottle per in each kit in SP 7435. So these are very convenient to have. These can be ordered if you want ready-to-use bottles when you set up the Autosampler. So here's a little bit of expanded view showing an example setup of an Autosampler, in this case the ASX-112, on a laboratory cart. And on the floor, you do see an appropriate waste receptacle for the overflow from the gravity drain from the rinse station. What I do want to point out, which is very important, is the end of the drain tubing should not be immersed in the waste liquid. In this case, the end of the tubing is actually attached to the fitting in the lid. If it is immersed and does get immersed in the waste liquid as it builds up, there is always the danger of backup in the rinse station and potential flooding of the Autosampler tray. So a setup like this, either connecting it to a port on the top of the lid, or if the lid is not there, making sure that the end of the drain tubing is well above the level of the liquid or anticipated level would prevent any flooding of the Autosampler tray from a backup. Okay. So the peristaltic pump is fairly straightforward to set up. Of course, though, you have liquid flowing over peristaltic pump tubing, and depending upon the type of tubing you use, there is always the potential issue of trace elements leaching off that tubing. A cleaner alternative to peri-pump tubing is something called a gas displacement pump, or a GDP. So here on the back of an ASX-112 Autosampler, you see the position of the peristaltic pump is replaced with a control panel for the gas and liquid supply. And what we do here is we pressurize two reservoirs of rinsed liquid, and the gas pressure is used to push liquid through tubing. In this case, it'll be fluoropolymer tubing and not PVC or thermoplastic elastomer tubing. And then that'll get pushed to the rinse station. So there is no contact with a flexible peristaltic pump tubing. So what I do want to point out is, in this case, you do need a supply of argon gas, and you see the tube there. And then there is a knob there that says flow adjust, and there you would adjust the actual gas pressure on the reservoir liquid, and that will then allow you to set an appropriate flow, speed of flow of liquid to the two ports on the rinse station, pre-rinse and full rinse. So expanding out, there you see the two bottles, and these are very different bottles from the ones I showed you previously. These are special PFA bottles, and they're developed to handle the gas pressure. You also see that there are some pressure release valves on each bottle to prevent them from getting over pressurized. There is a close-up of one of the bottles. Of course, those bottles will come as part of the standard kit with an autosampler if you order it with a gas displacement pump. You can order additional bottles too in kit SP6341 in case you wanted to devote a particular PFA bottle to a particular rinse solution and not have to change. So a few more close-up pictures. What I do want to point out here, and this is an ASX112, is the stackable nature of this particular autosampler, and this is being stacked on top of one of the Aridusll series desolvating nebulizer systems, in this case the Aridusll 2. And you can see some of the liquid lines that are coming up towards the rinse station, and of course the drain line leading down from the rinse station to the waste container. And the next picture just shows a close-up. Here you see there are two fluoropolymer lines, I believe probably PFA tubing, which attach to the two ports on the rinse station, and again the gravity drain that would then go down to the waste container. So again, in the gas displacement pump mode, there is no contact on peristaltic pump tubing. So, looking at the choices that you can have for racks and sample vials, this is what we'll call the short style or the low sample volume setup. The standards, there are 5 20 mil volume PFA vials and 9 4 mil volume PFA vials that are available as standards that can be put in the outside slots on the carousel or rotary tray. And there are 24, 48, or 96 position racks for the smaller volume vials, and these are either PFA or polypropylene, ranging from a half mil up to 2 mils in volume. So some more details on this. The short racks will have an adapter plate that sits in the middle of the carousel, and this is secured by 4 screws. And there you see around the outside of the carousel are the standard vials, the 20 mil and the 4 mil PFA vials. There's the short rack tray adapter kit that, of course, you can acquire and would need to have if you wanted to switch between a tall setup, which I'll show you a little bit later, and the short. And there is an example 24 position short rack in place in the middle of the tray, okay, right in the middle of that adapter plate. This is an example of what you might see in the host ICP-MS software screen, and this shows a diagram of that exact 24 position rack along with the numbers and positions of the standards and the rinse ports. So when you're setting up the system, of course, you can go ahead and you could actually do manual sampling if you wished through this screen. This also allows you to start thinking about setting up the automated sequence if you want to do that in the host ICP-MS software. But these types of utilities are available in the host ICP-MS software packages. So this will actually show the carousel tray movement, and there you actually see the rotary tray actually spin. And again, this would be on YouTube. I'm going to go back one and show it once more because that went fairly quickly. Okay. So there are two things moving in an ASX 110 or 112, the carousel or rotary tray itself, and then the Z-axis assembly and the Y-arm assembly. So you have several things that do move to position the probe appropriately over the chosen standard position or sample position. So just some more information on the vials and for both standards and samples that are available. The 20 ml PFA standard vials, of course, you would get one kit when you acquire an autosampler, but additional ones can be purchased through kits. So that includes the 20 ml PFA vials. A very useful little sub-accessory to the vials are these caps, and these caps are made of PFA and do snap onto the top of the vials. These have proved popular because it's not uncommon for users, of course, to make standards in the vials or also mix standard edition spikes in these vials, and the caps are very convenient for doing that. These are also available, of course, with the 4 mil standard vials. So again, very good for mixing. So not having to try to find some appropriate cap or to use parafilm for doing that. Here's also a kit then if you wanted to acquire additional vial caps for the 4 mil standard vials. So the sample vial rack kits, to give you some idea, here are the 24 position short rack kits, which are probably the most popular. You can acquire either 2 mil volume polypropylene vials or 1.5 mil volume PFA vials. The PFA vial volumes are a little bit smaller because of the thicker wall thickness or the greater wall thickness of the PFA vials, so they don't hold quite as much liquid as the polypropylene vials. Then there are similar polypropylene vials and PFA vials available for the 48 position. The 48 position for the smallest vials available, which are 0.5 mil. And then the 96 position, these are available only in the polypropylene. These are 1 mil volume. So this would be the largest sample capacity for the short setup. Then if you wanted to move to the medium sample volumes, and I mentioned, say between 5 to 15 mils, there are standard vials up to 30 mils made of PFA and up to 10 mils also made of PFA. There's a 42 position, what we call Bellart half rack, available for 7 mil polypropylene vials, and a 30 position rack available for 14 mil polypropylene vials. So just to show you some of the details, in this case, that short rack adapter plate is removed. So you would then loosen the 4 screws and remove the plate out of the center of the tray, and then simply place either the 42 or 30 position Bellart half rack directly in the center. Also notice that in this case, and I'll show you some details of this towards the end of the presentation, is a different rinse station is installed, which is just below the sample probe. Also around the outside of the carousel tray, you see the taller standard vials, the 30 mil and 10 mil PFA vials. So just some pictures of the 30 mil PFA vials. These, of course, are available in the kit. The same type of caps are available for these. If you want to mix standards directly in those vials. There are the 10 mil PFA vials. Again, these all go around the outside of the carousel tray. A close-up of the 42 position rack. This is a flat bottom vial, and it is threaded at the top for a cap. So 42 of these vials can fit in this particular rack. And there's the 30 position rack for the largest vials, 14 mil polypropylene vials, and these are round bottom vials. So I did mention in the benefits slide about the venting option that you can have for either the 110 or 112. There is a side vent port with a 5 centimeter diameter that you can attach to the integrated cover. And if you needed to remove acid vapors to a vent, you can acquire one of these side ports. A typical vent rate would probably be somewhere around 10 to 12 cubic feet per minute that you might attach to ensure that the vapors are removed. And there's the side vent port for an ASX 112. The part number is the same between each autosampler. So selection criteria, why would you then choose perhaps an ASX110 versus an ASX112? Well, earlier I did put in one of the early slides, some specifications, and for the ASX110, you do have a smaller footprint, although the Autosampler is taller. It's also a little bit easier to set up if you have a left to right sample introduction orientation of the host ICP-MS. And ICP-MSs do vary among manufacturer models depending upon how that sample introduction orientation is set up. For the ASX112, you did see an example that it is stackable. So if you do have a desolvating nebulizer system like the Aridusll 2 or the Aridusll 3, you can save laboratory bench space by stacking the Autosampler on top. Also, this is a little bit easier to set up, meaning a shorter sample flow path to the host nebulizer if you have a right to left sample introduction orientation of the host ICP-MS. So here's an example then of the ASX112 stacked on top of the current model Aridusll 3 system. And of course, overall, that is saving bench space. And on top of the previous model, Aridusll 2. So in each case, the ASX112 is stackable. You still could use an ASX110, but the taller length means that if you stack it, it's harder to get a requisite length of the probe to reach down to the Aridusll 2. Again, you could set an ASX110 next to your Aridusll system, but you would then be using up additional bench space. So here's an example of an ASX110 set up next to an ICP-MS model with a left to right sample introduction orientation, in this case, an Agilent 7700 ICP-MS. The next example in this case is an ASX112, and this is set up next to a Thermo ICAP Q series ICP-MS, and this one has the right to left sample orientation. And the way the ASX112 Z-axis assembly and wire assembly is set up, this gives you a shorter flow path into the host nebulizer. Finally, here's another picture showing, in this case, an ASX112 again on the sample introduction tray of the Thermo Neptune multi-collector ICP-MS. And again, that has a right to left orientation. Also, you see there the 2 sample reservoir bottles. These are the large 2-liter polypropylene bottles if you're equipped with a peristaltic pump. And those are simply placed on sort of that back tray on the back portion of the ASX112. That's commonly done. So maintenance and troubleshooting of an ASX110 and 112, certainly a Autosampler probe may need to be replaced from time to time if there's potentially an issue with sample buildup or a blockage, say, from a sample particulate. There again are the IDs of the various probes available and their spare part numbers. Certainly, if you have a peristaltic pump tubing, a peristaltic pump tube equipped ASX110 or 112, and the tubing starts to wear, there are a variety of kits available, either the thermoplastic elastomer tubing or the PVC tubing, and there are various kits with various ID of tubing depending upon the rinse solution flow rate needed. Or if you needed to replace the actual rinse station liquid supply tubing for either the peristaltic pump or the gas displacement pump, there are also kits available for that. This is one thing in case there could be a contamination issue and you needed to, say, wash out your reservoir bottles. You may also need to wash out and or replace the supply tubing to the rinse station. And here are some pictures of some of the kits. There's an example peri-pump rinse kit, which contains, in this case, PVC peri-pump tubing, along with the transfer and the gravity drain tubing. And on the right, there is the full kit for the gas displacement rinse kit. Again, the PVC tubing in the middle there, again, would not carry any of your rinse solutions to the rinse station. That would be for the drain, the gravity drain from the rinse station down to the waste. The supply of liquid to the rinse station would be through the fluoropolymer tubing and would not touch peristaltic pump tubing. Troubleshooting, well, one of the easiest first things, of course, is to check the power system, checking that the power supply is correctly connected, the power switch is on. And certainly you want to check that the green LEDs on both the front of the ASX 110 or 112 is on, and then again on the power supply in case there could be an issue with that. And the arrow on the lower right shows the position of the LED. So it's always good to check that the power supply is active to make sure that that is working properly. Communications, again, can be either RS-232 through a serial cable or a USB cable. Again, you want to check that those are plugged in properly and that you have selected the proper COM port for either RS-232 or a USB cable. And then finally, software configuration problems. This could be whether or not you are getting communication from the host ICP-MS software to the Autosampler. So one of the things to first check is the computer itself. There is a terminal program that is supplied on the CD with these Autosamplers called CTerm. And you can use commands such as home, rinse, position commands, turning the pumps like the peristaltic pump on or off to see if you have established communications between the host computer and the Autosampler. If the manual commands work, then you'll want to check if the host software is actually configured for the appropriate COM port that you're using for communication to the Autosamplers. But CTerm terminal program is often very useful for troubleshooting any communication issues. Alignment problems, which can happen. There is an alignment program available on the CD, also off the CETAC website, which allows the user to realign both the rotary tray and the Autosampler probe. And there is a little point denoted by the little black dot for the tray alignment point that you would align the sample probe over, and then also aligning the rinse station. And there's also a rinse station alignment point between the two ports, the pre-rinse and the full rinse, to align the position of the probe. So there are links then. There is a link below to the CETAC website, and you can go in there to find additional links. If you do need to download the pump speed utility, the alignment tool, or the CTerm terminal program, those are on the CD that come with the ASX 110 or 112, but if the CD is lost or misplaced, you can also get those from the CETAC website. One thing I do want to point out, which sometimes does happen during the troubleshooting process, are these two control switches on the bottom panel of the ASX 110 or the ASX 112. There are two small metal plates that you would then remove or loosen with a small Phillips screwdriver, and there are small dip switches that are used to control the Autosampler set type, or whether the Autosampler is set for the short or tall configuration, depending upon whether you're using the short or the tall Autosampler racks. I just wanted to point these out so you know where those are, but you would only use these with the assistance of the CETAC service team. They would give you more directions on how you would then set the appropriate small switches on the two switches. The one that I'm pointing at is typically the most important one with the 8 dip switches, but normally the users would not go into these unless they did need to make a configuration change, say they're moving from one model ICP-MS to another or short to tall. Certainly do that with assistance from the CETAC service team, and they'll be happy to help you with that. So I do want to mention a couple details about if you want to acquire one of these auto samplers. There are top-level part numbers that you would order, and these are the example, what we call the 99 level numbers. And there are different numbers depending upon whether you want to order one with a peristaltic pump to supply the rinse station or a gas displacement pump. The gas displacement pumps, those two models will come automatically with a PFA rinse station. The peristaltic pump equipped systems will have the polypropylene rinse stations. You could acquire a PFA rinse station if you wished via one of the SP kits if you wanted to go that route. And then once you have chosen your top level part number for an ASX 110 or 112, you then finish the configuration steps by choosing your kit type, whether you want to use the short or tall setup, which rack kit you want to start with, which sample probe you want to start with, specifically the ID of the sample probe, and the firmware for the intended host ICP-MS. So again, peristaltic pump or gas displacement pump equipped, whether you want to use the short or tall racks, the rack kit you want to choose, the sample probe, and finally the firmware for the host ICP-MS. So compatibility with current ICP-MS models. Here are the models that the 110 and 112 are compatible with. For the Agilent, I do want to note that the 110 and 112 are compatible with the short setups only at this time. But then Analytic Jena, New Instruments, Perkin-Elmer, Thermo Fisher, depending upon the model type, can do both either the short or the tall. I did want to point out just a little detail about the short or tall rinse kits. Here's an example of a short type rinse kit and the pieces that would go with it. Of course, you note the short rack adapter plate there that you would then put in the tray. The rinse stations themselves are very easy to swap out. They're simply secured via two large thumb screws, and those are denoted in that picture. So they're very easy to change out if you do need to change out between short and tall or back tall to short, depending upon the sample volumes that you want to run. Application notes that are available for the 110 and 112. For the 112, the ones that we do have available are on the website, and there are the links. These all entail use for semiconductor work, and you can see ultratrace elements, hydrofluoric acid, isopropyl alcohol, and photoresist solvents with ICP-MS detection. So you can go to the CETAC website and then look at more details on those notes. I've also selected some literature references using both the ASX 110 and 112. Here for the 110, you see examples, and these are all with regards to using with multi-collector ICP-MS for geological applications. And then for the ASX 112, the first two at the top, and these are fairly recent applications, are for geology. The bottom one was actually for a clinical sample studying uranium isotope ratios in urine using a high-resolution ICP-MS, not a multi-collector. And that gives you some idea of the variety of different applications that the two auto samplers are used for. And then finally, where to go for more information. So there are emails for service support. And as I mentioned, like say for changing the control switches on the bottom panel or any other troubleshooting item, you can contact CETAC customer service through that email. Sales support, if you do want to acquire one of the systems or acquire spare parts for the system, you can go to CETAC sales. Technical support, certainly to myself, Fred Smith, and my colleagues Andy Perry and Paula Duscott, or directly to the Teledyne CETAC website. There you see the links to directly on the website for more information on both the ASX 110 and 112. So again, if you have any questions about the ASX 110 or 112, please email to myself at fred.smith@teledyne.com, and I'll be happy to answer your questions as promptly as possible. And again, the 2 short videos that we showing the movement of the sample probe into the rinse station and the actual movement of the probe out to the sampling tray where the carousel or rotary tray is moving. Those 2 videos will also be available on YouTube in case there is a bandwidth issue looking at them through the PowerPoint. So with that, that will conclude the webinar for today. And again, thank you very much for attending. Again, if you have any questions, to fred.smith@teledyne.com. And thank you again to Shelley for the introduction and for the setup of the webinar.